You get to get me on a tangent again. Jeez. Okay. In-depth TCP/IP. Again, in the 5th edition, this is chapter 10. It's very similar. Okay? Let's talk about it. All right. So we're going to talk about how stuff actually works. Mainly subnetting and stuff like that. Okay? So, TCP/IP, first of all, gives us internet connectivity. Is anyone using the LTE yet? The high-speed internet on the new iPhone? Very fast. 11 meg download. It's like crazy fast. So, all right. Internet connectivity, private connection data, it gives all kinds of stuff. IP addressing, routable stuff, interfaces, unique IP addresses, multiple IP addresses, just all kinds of stuff. Talk a little bit more about how they're assigned dynamically. Which protocol assigns them dynamically?
DHCP.
Yeah. Very good, DHCP. I think you got that one right. But yeah, we're going to talk a little more about that. Subnetting. This is what the majority of the chapter is about. So say we're at OU. Some of you know where OU is? Big waste of money. I mean, some of you think that's your life, probably. Is anyone in here a diehard OU fan? I had a good friend of mine filed bankruptcy. Right after that, I was sitting there, she was on their website, and she was talking to her husband, oh my God, they came out with a whole bunch of brand new OU shirts. Which ones should we get? You know what they said? One of everything. You just filed bankruptcy, and you're buying all this. And her husband, one time, I was there because he worked for a place I used to work. And he said, oh, going to the game. I said, yeah, what happens if your boss tells you need to work? Nope, going to the game. Yeah, whatever your boss said, you're going to. He goes, you don't understand. I don't care who tells me anything. I will be at the game. That's it. Dude, that is way too much of your life.
Man. I'm not stupid fan.
Yeah, he was like, ooh, crazy. Okay, but back to OU. Can you imagine if we taught this class in a room with 400 people? OU does some of that. A lot of big schools do that. They have lecture halls, a whole 400, tons of people. How much interaction do you think you get from that? Zero. By the end of the class, I have a real hard time with names, but there ain't no way those instructors are going to know your names. So what if we broke it out into smaller rooms? Actually, that's a selling point for our school, is the amount of students per class. So it's kind of what subnetting is. We take a huge network. So Class B network handles what? 16,000 clients? Or B is 65,000.
Yeah.
Okay.
A's,
16 million. Something like that. Yeah, a B can hold 65,000 clients. Okay. But with a network, not talking switched, but say it was a hub or something, but switch change it up a little bit. But on a network, only one person can talk at a time. Can you imagine if you're in a room with 65,000 people and only one person can talk at a time? Or even at OU with 450 people, how could you possibly ask a question? So with subnetting now, we break that large network down into smaller pieces. So now we have rooms of 20. Could you possibly get a word in a room of 20? Sure. That's what subnetting does. It breaks our network into smaller pieces. Okay? Multiple logically defined segments or subnets. Geographic could be by location, could be boundaries, could be technology, all kinds of different ways. Okay? They separate them from each other. That's what a subnet does. Very important. When I worked at Tinker, I went to this one office. I might have already told you this, but I went to this one office that had one machine would work, next one wouldn't. And no one could figure out what the problem was. And since I was kind of forced into the networking shop, if you're so smart, go figure out what the problem was. I went over there, and they all had different subnet masks. And I says, why? They're like, oh, those aren't important. Obviously they are. It's like a zip code on a letter. Can you imagine writing a letter, putting the wrong zip code? What's the odds if you're going to mail me a letter and put a New York zip code on it that I actually get it? It ain't going to happen. That's what a subnet is, like a zip code. Okay? Reason to separate it, enhance security. Maybe we want to keep our traffic internal here away from somebody else. Okay? Improve performance. Obviously, if only one person can talk at a time, at least, it would be faster this way. Simplified troubleshooting. Hey, if this entire room goes down, do you think we got a problem with that machine right over there? Probably not. It's probably something to do with the connectivity outside the room or farther up. So, nice things there. Okay? All right. They have class full and classless router. Talk about both. Classful, that's what they first came out with. It's kind of like anyone ever buy a computer with the whole 640K of RAM? No one bought a computer in the mid-80s? Yeah, it wasn't alive. I bought one, 640K. I upgraded it to 1 meg. Then I spent the big bucks and upgraded to 2 megs. And then I think my next computer, I spent $600 for 16 megabytes of RAM. 16 megs. I mean, it's like, what the hell? Okay. Kind of the same thing with IP address. And they had a great idea. But who thought everything in the world would have a darn IP address on it? Did they think 15 years ago that I could view my cameras, set my thermostat, open my garage? I was in California this weekend, and my son had to go in the house. I remotely opened up the garage doors for him, had the cameras up, and I was like, Nick, you left the laundry room light on, so he wouldn't turn the light off, and I closed the garage door. I forgot he had a code. And what sucked was, afterwards, I was putting in my phone to shut the garage door. It would start shutting, then it would open again. Like the damn cat, because I got cats that run underneath the door. Crap. So I hit the closed door again. I'd wait a minute, hit close door, then the door would open. My son was putting in his code. So he would wait a minute. Okay, so he put in his code, closed, then right then I'd hit my button and the door would open. so finally, he calls me, Dad, you're fighting me. I'm shutting the garage door. I'm like, oh, I thought it was the cat this whole time. It was funny. But, who would have thought you could do that? My son is on a cruise ship right now, and they're doing a test program. They've never done this before. He's on the Carnival Magic. High-speed internet, unlimited. They've never had that. He's text messaging me, emailing everything. He even did FaceTime with me from the cruise ship about an hour and a half ago. That's never been available on a cruise ship before. But internet on cruise ships sucks if you don't know that. It's like you could almost write it faster by hand. But now they have high-speed internet, 20 times faster than normal, which is basically slower broadband speeds. So, and it's unlimited. It's like, what the hell?
I guess they're doing it through satellite?
Yeah, but they just changed the technologies. So, yeah, it's through satellite, but it's a new way of doing it. I don't know exactly the way they're doing it, but so they came up with a whole plan here, and it was based on your network type. Your network, was it A, B, or C? Your network class. That's how many things you had. Okay, so we had A, B, and C. We also have D and E, multicast and experimental. Okay, drawbacks. Fixed network ID size. We basically, hey, you got a Class A network, you got 16 million hosts. You got a B, you got 65,000. You got a C, you got 250. It was, it's like we can't have a room with 20. You either got 65,000 computers or 250. There's no. Think about it. If you're running a company, couldn't you possibly need more than 250, but less than 65,000? I mean, isn't that kind of a big jump? Yeah, I could definitely see that. There's a lot of companies that are 500 people. So if you need more than 250, I have to give you 65,000? No, that doesn't make sense. But that's how they set it up initially. Because they didn't know what people would need. Okay? Difficult to separate traffic. So they basically said, this is a bad idea. Okay? What they came up with was a Class A network. The first octet, or the first 8 bits, were the network ID. Okay? The last 28 bits, is that right? Yeah. Okay? No, 24 bits. Is that right? Yeah, 24. The last bit are the host information. So out of all those available, there's 16 million different combinations. So that's one big network. Do you agree with that? So there's a very small number of them. There's only 255 networks, but each network has 16 million computers on it. Okay? So we went to Class B. Well, now we got 65,000 different networks, and each of the network can have 65,000 computers. Okay? But what if I needed 1 million computers? I'm either going to have 65,000 or 16 million. Isn't that a little overkill there? Is he an issue there? Well, let's go to Class C. Now we have 16 million different networks. They're all 250. But again, if I need 500 or 1,000, ain't going to happen. Oh, I'm sorry, you can't have 1,000. You must buy 65,000 of them. I mean, I bought some ceiling tiles at Lowe's. And it's funny, I bought like 3 boxes or something. And each box had like 10 in them. Well, I didn't use them all. And I don't know if you know this, but you can bring back a partial box and get your money back. Well, I didn't notice what they were doing. I brought back like 8 tiles. So I brought it back. They gave me a refund. Later on, I go look at my receipt. My receipt is like 3 times more than I originally paid. They credited me back 8 boxes instead of 8 tiles. So I bought 3 boxes, but they credited me back 8 boxes. So it was. But can you imagine buying ceiling tiles if you either get to buy 8 or 65,000? What if I only need 10? I'm kind of screwed. But that's kind of what this was. So you can have 255 computers on your network. Oh, you need more than that? I only need 5. I'm sorry, dude, you're buying 65,000. No, that's crazy. But that's the way it was originally set up. Okay. All right. Here's an example. Class A net. Okay, that's correct. So the network information is the first octet on a Class A network. Remember, the Class A is the first part. So the network information for Class A is 114. Y'all following me? Okay. The host is 56204.33. That's the host number. Now in Class B, the network information is the first 2. So it's 147 and 12. The host is the last 2. On a Class C, the network information is, the first 3. And this is computer 7 on network number this. Okay. So really, what they do is they just broke it apart. That's A, that's B, that's C. Okay. So, all right. IP mask. It says identifies how the network will be divided. Okay. Indicates whether the network where the network information is located. We'll see how that works. Subnet mask is either 1 or 0. Everything in this is all binary, by the way. You all know what binary is? Let's cover binary real quick. They don't really cover it in here. All right, I'm going to walk you through. Actually, I'm doing it on the computer, so it'll be on the recording. All right, we're going to count in a numbering system. Hopefully, you all know 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Everybody with me there? Get rid of the line. Hold on. Where's my mouse? View. Line numbers. Configure preferences. Actually, let me save this as. Let's save this as text file. Configure preferences. Text. Fonts. Get on here. Courier new. COU Courier new, and I want size 20. And bold. Alright, can everybody see that okay? This is decimal. Is everybody familiar with decimal? What happens after I get to 9? 10. Okay? 11, then 11, 12, so on and so forth. Now when I get all the way down to, 19, what happens after 19? 20. You guys are good at this. Some pretty complex math going on here. I'm down to 99 now. What do I do now? 100, okay? Easy enough. So what we did was we got to our maximum number, change it to a 0, increment the next number. You all follow that? We got to our maximum number, change it to a 0, increment the next number. You all agree that's what we're doing? We got to our maximum number twice now, change both to 0s, increment the next number. Good enough? But it's very confusing because we have to worry about 10 different numbers, 0 through 9. Well, let's talk about binary. 0, 1. I'm at my maximum number. So what do? What do we do up there? What did we do when we reached 19? Change to 0, increment the next number, okay? So you mean that. Okay? So let me move this over a little. Everybody following me there? What we did? Now what's the next number?
11.
11. Well, now we're here. So what do? Change both the zeros, increment the next number. Everybody following me? It's easy. All we're worrying about is two numbers. Can anyone juggle in here? I can juggle one item. That's about as far as it goes. Okay? I can juggle one. But, I could probably, with enough practice, learn to juggle two. So would you agree that juggling two is harder than one, but it's easier than 9? Then why are we so darn happy with this thing? We've got to juggle 9 numbers. We've just been doing it a long time, that's all. That's all it is. Isn't it a lot easier to juggle 2 things? So isn't it a lot easier to count only 2 numbers? But, it's like metric system. In Europe, that's all they have. I spent 7 years over there. 3 weeks in, you're done. That's all you need. You figure it out. It's not that hard. It's 120, 75, liters to gallons. Heck, when we buy sodas now, what do we buy sodas? Can you buy a gallon of soda? No, you buy a 3 liter, a 2 liter, a 1 liter. So we're already using it, but we just don't realize we're doing it. So we're already doing this stuff. But the 0, 0, so what number is this in decimal? This is a 0. So that's a 1. So what's this one? 2, 3, 4. So what would the next number be? Okay, 101 is what? 5? Then what's the next number? What is it? 110 is 6. Then what? How about that one? 7. Okay, now what's the next one? We're at 99. We're at 999 now. 1,000, which is 8. Easy enough to do? See how simple that is? That's binary. And on a computer can do one thing. A computer is like this baby right here. It's on, it's off. That's it. It doesn't have varying degrees of intensity of all. With a computer, it's either on or off. So that's what binary is. And that's why a subnet mask uses binary. It's either the host ID or the network ID. We didn't say anything about that. Well, you are half of the host. No, you're either the host or you're the network. So subnet mask is all 1s and 0s because it helps us identify the host from the network. Okay? Everyone with me so far? Hopefully I covered that low level enough. But so many people have a problem with binary. I even have a binary watch, but I don't wear it that often because I don't use it enough. And, does anyone speak another language in here? No one speaks another language? Not even a little bit? Uno, dos, tres, you got that? But, you ever get to the point where, you actually can think in the other language? I've been to Spain, Italy 17 times, Spain probably 10 times, spent 7 years in Germany. It got to the point where you just don't have to convert it anymore. You just know it. Like Ausvater, exit, stuff like that. And, Wiedersehen, which is, hello, all that, oh, that's goodbye, actually. But, the point is, you got to the point where you used it so much, you didn't even have to think about it. But if we were that way with binary, if we just started using that forever, we'd be set. That's why a lot of people learn other languages. They just totally immerse themselves. And, my wife had never been to Italy or Spain. And I went there over the summer. She knew nothing in Spanish or Italian. She learned a whole bunch by the time our cruise was over. Because you didn't have a choice. Well, actually you do. Because nowadays when you're American, you go to Europe, guess what? They want to speak American too because they're trying to learn English. But, a lot of stuff, she learned quite a bit pretty easily because we were kind of in it. Okay? All right. So, subnet mask. 1 is the network. 0 is the host. Okay? So we're going to see an example of this in a minute. Okay? Okay, the network class has default subnet masks. Okay? We're going to see. Okay? All right. There's an A, a B, and a C. See all the 1s and 0s on there? Remember I told you the first octet was the network ID in an A? Then all the rest were hosts? Look at that. The subnet mask of 255.0.0.0 was a class A subnet mask. 255 happens to be all ones. Isn't that kind of handy? Class B is 255.255.0.0. The ones tell us the network. The zeros tell us the host. And class C is 255.255.255.0. Okay? So here at Rose State, let's look at what our subnet mask is. Okay? Let's find out. My subnet mask on this machine is 255.255.0.0. Is that A, B, or C?
B.
That's a B. How many computers is that? Well, let's find out. I'll show you how to do that too. Have you ever seen a calculator before? If you view scientific, all right, with binary, okay, with binary, how many zeros do I have here? 16. So it's 2 to the 16th power. So we're not, remember, the old decimal system was 10 to the whatever power. Or 10 to the 1, 10 to the 2, 10 to the 2 is 20, 10 to the 3 is 30, that kind of stuff, you know. But, yeah. So 2 to the 16th, that's how many hosts we have. Let's look. So in this calculator, I go 2, now click on this to the power of button, 2 to the 16th, 65,536 hosts. That's how they get those numbers. So we just found out that Class B, like we have here at Rose State. So why would I do that? Why would I, on my cybersecurity network, which only encompasses room 201, 214, 211, and 220, 4 rooms. I'm not thinking I see 65,000 computers in here. So why would I possibly do that? Any ideas? Well, for different projects, and since different schools also use our network, I wanted to make it so you can have like your entire range all to yourself for whatever you wanted to do. Like we have 10, 10, 0, whatever, that's our infrastructure. 10, 10, 10 something is something else. We wanted just so we could keep them separate because we didn't know what other schools would want to use. But in reality, was that a good idea? Probably not. We don't have 65,000 machines. At your house, most of you have this one. You have a Class C. So let's see how many computers that is. So how many zeros we got here? We got 8. Is that right? Everybody agree with that? So if I went 2 to the 8th, 256. So it's your house right now. You can have 256 computers. Good idea or bad idea? Works. We all use it.
Video games and all the other wireless devices that you
To happen a little overkill, maybe? I have like 40 on mine. 40 or 50. Let's go for 100. Why have 256? It's just easier. Because it's already set up for us. But could we make it more secure? Heck yes. We could lower it to just what we need. And we're going to see how to do that. Because by leaving it that big, where I can have 256 in my house, I forget to set my password this week. Now 250 people in my neighborhood could all go to my network at the same time. Whereas if I had my subnet set to a very small number, maybe only 100 people could get on. Or 50, or whatever I set it to. So, and another thing to think of it like, you know, the number of phone books you can remember, number of phone numbers you can remember. 256 is quite a few. And computers are really fast nowadays, so it really doesn't matter. But still, the computer, if it wants to talk to somebody, it has to send it out to the whole entire subnet, all 256 basically. But if your subnet was smaller, maybe only 10 computers, or 12, or 20, sending out to a smaller bunch, it's less traffic. So there's benefits of making it smaller. What you want to have is a subnet that's as small as possible, but not negating use. I mean, not making it so someone can't do what they need to do. Like if you need something, yeah, we'll give you the number. You know, make sure you got enough for what you need. I would hate to be at my house and sit there, darn it, I can only have 8 things on at a time. So let's turn the TiVo off so I can use my phone. Or nope, can't change the thermostat today because I just switched the light on, or I closed the garage. That would suck. So
if you're doing it for security purposes, you can update that every time you had a device, right?
you could, yes, you could. But you know, the whole usability, you know, the CIA triangle, I don't think we've talked about it in this class. Did we? I don't think so. You probably heard it in another class. If not, you will. The big three: confidentiality, integrity, and availability. So many people screw up in availability. They know what confidentiality is. You know, I want to keep this stuff secret. Integrity, the data has not been changed. But they go so big deal on confidentiality and integrity, they screw up availability. If I have to put 15 passwords to log into the system, yeah, very confidential. But what are the odds of me being able to use it with 15 different passwords? It's going to suck. So the availability is a big deal. So you don't want to get a subnet that's so small it's going to cause issues. Again, you don't want it so big it's going to cause issues either. You want to go as small as possible. We'll see how to do that. All right. Okay. Is everybody with me so far? How many different networks are there here, according to what you see on the screen? For Class A, 256. Yeah, 8 to the 5th. No, 2 to the 8th, sorry. 255. Yeah, 255, yeah. But there's more to do with that. We'll see in a minute. So there's actually a very small number of networks, but each one of those 255 networks are 16 million in size. Now let's see. We didn't count those. So how many is here? How many zeros? 24? Let's do that one. We didn't do that one. So 2 to the 24th power. What in the digits are wrong?
You didn't clear it out before we entered it.
Oh, I did? Okay. 2 to the... Yeah, where is the clear on this one? CC? I don't see CE on this one. Oh,
Right
duh.
next to
Duh. It's hidden. It's hidden. So 2 to the 24th. What the hell? 2 raised to the 24th. There it is. It took a few times, but we got it. 16,777,216. Small number of networks, 255 networks, but man, are they big. Okay. Medium number of networks, medium size, 65,535, 65,535. A whole bunch of networks, 16 million networks, but they're all teeny tiny. They're all 255 each. So far, so good? What kind of with me? All right. Anding. Okay. Anding, combining bits. Okay. So 1 and a 1 is a 1. Okay. A 0 and any other bit is a 0. So 1 and a 1 is 1. Everything else is 0.
Every time I went for Boolean,
Yes. Yeah, Boolean is what we're doing. Boolean is on or off, 1 or 0. True or false. Yes, same thing. Okay, so let's... did they show it on the next one? Okay, let's look at this and we'll come to it. Okay, so here we go. If we have a 1 and a 1, we get a 1. 1 and 0, we get a 0. 0 and 1, we get a 0. 0 and 0, we get a 0. So for AND... So, okay, so we're going to go to work in the morning. What are some criteria for going to work? We're going to base it on day of the week and time. Okay? If it's Wednesday and it's 8 in the morning, should I be at work? Yes. But if it's Wednesday at 4 in the morning, should I be at work? No. Or Wednesday at midnight? No. So they both have to be true for me to go to work. But what if it's 8 in the morning and it's a Saturday? I'm not going to be at work. So basically, they both have to be true. Binary ANDing, they both have to be true. So 1 and 1 is 1. 1 and anything else, I mean, anything with a 0 and is 0. It's not true. Everybody with that? Now, if we convert our IP address, which we haven't done yet, but we'll pretend. If we convert our IP address to binary, which we're going to see how to do in a minute. Over here we got an IP address. We convert it to binary. Then we put our subnet mask. The 1s identify the network. So first of all, where is the network on there? Where's the network end? Does it end there? No. End right there, because see, that's where the zeros start. The zeros start over on the 4th octet. So basically what's happening is we know the first 3 are network, and the last one's the hosts. Now with ANDing, okay, what they do is they take this and they AND them together. So if I'm going to send something to Jason, it is Jason, isn't it? Okay. My computer looks at my IP address and my subnet mask, ANDs them together. Then it looks at Jason's, ANDs them together. Do they match? If they match, we're on the same network. Because remember, anything with a 0 always turns into a 0. So all the hosts end up with 0. So if we AND our IP address and our subnet mask together, they do the same for me and the same for him, and if they match, we're obviously on the same network. They have to be. But if we're not on the same network, we won't get the same thing. So what happens is when I do that, my computer ANDs mine together, then ANDs Jason's together, and they match like, oh, Jason's on the same network. So it does not send it to the gateway. It says, oh, Jason's inside. It makes a unicast, talks to him directly. Okay. Now, if it did it, say I was doing it with Google. It would take the IP address and subnet mask of me and AND it together. Then it would take Google. It doesn't know Google's subnet mask, so it'll use mine. But still, it's not going to match. I'm 1010 whatever, and it's not going to match. I'm like, oh, Google's not in here, so it ain't talking none to you. It's going to send it straight to the gateway. Okay. All right. Let's.
Would you
Got
program the subnet mask in like your router or your switch?
Some routers and switches have them. Some do not. This is a $200 switch. Ain't no IP address on it. Down the hall, we got some $3,000 switches. Yes, there's an IP address on those.
Is that the difference between managed and unmanaged?
Exactly. Managed, you actually connect to the switch, and you can turn ports on and off. You can do port mirroring. You can do VPNs. All this stuff from the switch. That's managed. And that's $3,000. I mean, you can buy cheaper than that, but all right. Let's talk a little bit more about binary. Okay, we got the basic gist of it. Well, I'm trying to do this all on the computer so we can see it on the recording. How can I do this? Let me think. I'm back here. Okay. Okay, so how am I going to do this? 2 to the 1, 2 to the 2, 2 to the 3. I don't feel like I have to make them up. That's like 2 to the first power, 2 to the second power, 2 to the third power. You okay with that? Everybody okay? That way I don't have to figure out how to do the whole. I probably could quite easily. Probably could do, let's see, font somewhere, font. Nah, I'm messing with it. Okay, so let me finish this up. 2 to the 8th, 2 to the 7th, 2 to the 6th, 2 to the 5th, 2 to the 4th. Okay, is that all of them on there?
Didn't get 2 to 0.
I don't need that. Oh, don't do that. I'll make you happy. All right. What is 2 to the 0? Anybody? That's 1. 2 to the 0 power. Any number to the 0 power is 1. Okay? Okay, so what's 2 to the first power? So, a little refresher about exponents. So, if I was going to write 2 to the first power, that means 2, not to the 2, it's just 2. I mean, use it one time. So, 2 to the first power is 2. Now, 2 to the 2, in other words, 2 with a little 2 on top corner, that means 2 times 2 is what? 4. Okay. What's 2 times 3 then?
8.
I got 8, a 6, and a 3.
2 to the third power, you mean?
Yes.
2 times 2 times 2.
So it's 2 times 2 times 2. And these are getting longer each time, aren't they? So I'm trying to do it so people who watch the recordings can see it. So 2 to the 4th power.
15.
16. Does anyone see what's happening? It's doubling. Remember, in tens, it went from 10, to 100, to 1,000, so on and so forth. It basically added a 0 at the end each time. Here we're just doubling. 1, 2, 4, 8. So what's the next one? Okay. do you think? Everybody see that? Okay. So, if we had 8 zeros, what do we have? So 2 to the 8th is like 8 zeros. So it's 256. What if there was 3 zeros? 3 zeros. 8. Okay? If you can remember this, your life is so simple. When I went in to take my certification test, I wrote that on the board, on the piece of paper they gave me. Answers everything for you. Good. Now, let's see how to do this, okay? Now, I'm going to give you a number. Normally it's easier to write on the board, but I just want on the recording. So, I'm going to give you an IP address, and the IP address is 192 is the first digit of it. I want to convert that to binary without a darn calculator. Okay? Now, so how do you think I should start? Any ideas? How about if I start from the left? Sound good? How many 256s fit inside 192? How many 256s fit into 192?
0.
So, there's 0 there. Whoops. Can we fit a 128 inside there, though?
Yeah.
Oh, yeah. So we need one of those. So we can take this number, minus 128, gives us what? Anybody?
64.
64? We're gonna verify your math there. 60. Okay. So how many 64s can fit in there? 1 minus 64, what do we get?
0.
So what else? What's the rest of my number?
0.
So 192 converted to binary is 011000000. Do I need to include the 0 at the front? If I'm going to pay you $10 or 010, is it the same amount of money? 010? Same amount of money. So like, I'm going to pay you $10. I'm going to give you 0 50s, 0 100s, 0 1000s, and 110. So, yeah, zeros at the beginning don't matter. Zeros afterwards really matter. Let's see if we did that right. So if I went into, let me show you another thing about the calculator. If you go into View Programmer, okay, View Programmer. Now if you have prior to Windows 7, like XP, something like that, it's View Scientific. But so let's put in 192. 192. Okay. Now let's convert it to binary. Were we right? Remember, the beginning zeros don't count. So we have 1 1, 1 2 3 4 5 6 zeros. 1 2 3 4 5 6. Yes. Everybody see that? Yes? Everybody happy? Let's do another one. Let's do 66. All right, 66. So how many 256s can fit into 66? None. How many 128s? None. Can we fit a 64 in there?
Yeah.
Heck yes. I mean, then you should be able to see what the rest is. Easy enough. You're like, so 66 minus 64 is 2. Very good. Man, you guys are good. So we want none of these guys, none of those guys, none of that guy, none of that guy. We want one of that guy, none of them. Let's see if we did it right. Let's go. Actually, this time we'll put it in binary. 0 0 1 0 0 0 0 1 0. You agree that's the same number? Now I want to convert it back to decimal. Yes, look at that, 66. Everybody following along here? We're converted back and forth. It's really pretty simple to do. Okay, but if you could write this down, if you can remember that, isn't it pretty darn simple to convert it back and forth? Like, how many took it? None, 0. Oh, we can fit one of these, none of those, and it's so easy. So even when I went and took the certification test, I'm real big on remembering certain key components and using it. So easy to say. Okay? All right, I'm going to peek ahead real quick at the slides. Okay, good. They do cover it. Okay, I was worried they were going to skip something. Okay. Is everybody okay with that so far? No big questions? We're not out of time yet, so. I wanted to see if they were going to cover something else here in a second. Okay. There are some special addresses. There are special stuff that not routable, stuff like that. Okay, cannot be assigned to a network. Use the subnet masks, and we're going to see, like, you cannot assign yourself 255.255.00 as an IP address. That's going to be let's try that. I've never tried that. Let's try that. Go to the control panel. Let me go to networking, adapter settings, low clear connection, IPv4. Give myself an IP address. Nope, can't do it. So I can't use 255 as an IP address. Oh, I went to right here. I went to networking. Are you there? Okay, I'm gonna go back one. For Jason, we'll go back. I'm here. In the control panel, I'm gonna go to networking, networking sharing center. Then I'm gonna top left, click on change adapter settings. I'm gonna click on Rose Labs. With me there, Jason? Right click, properties. TCP/IP v4, IPv4 properties. Use the following address, 255. Can't do it. Hold on, here.
I don't see you doing it there, Jason.
Properties. Okay. IPv4 properties. Use the following address. Type in 255. There.
2.1 and 223.
Yeah, 1, 2, 23. So you can have certain numbers in there. We'll cover more about that. Okay, so we know we can't do it. Forget that. Didn't work. Okay. So there's certain addresses. Okay. Use the subnet maps. Okay. Examples are network ID, broadcast, that kind of stuff. If I want to get mail to my house, could I send it? I live on 8412 Tree Line Drive. Could I send it to just Tree Line Drive? No. They'll be like, duh. Now, my mailman knows me, so they might be able to figure it out, but assume they don't know me. They wouldn't know where to deliver it. So what they're saying here is you can't use a network ID. A network ID is like your street name. Which network are you on? Remember that where all the ones were under the network? That was the network ID. The rest were the hosts. So you can't just send a mail to Tree Line Drive. It just ain't going to make it. You also can't use broadcast. We'll talk more about that. All right, here's some other ones. 127.0.0.1. That's the loopback address. Okay. What's handy about that is if you want to test internet connect or your network card connectivity, do this. Let's go. Command prompt and type ping 127.0.0.1. What it's doing is it's sending a packet all the way down to the last layer, then all the way back up to the top again. It's testing. I typed ping 127.0.0.1. And it tested the entire network all the way down to the cable. Now, did it verify the cable's any good? No. But at least tested that the network was configured correctly. Okay? So that's what a loopback address is. Can I assign that as my IP address? Well, it's already your IP address. I mean, you don't have to do it. It's one of those things that automatically does it. Does anyone know how to figure out what your computer name is? Host name. Type host name, it tells you what your computer name is. Why would you possibly need that? Somebody asked me that. Why? That's like stupid. Why would you do that? Remember that your name can change to anything. Computer has to figure out what its name is. So the computer says, hey, host name. Oh, that's my name. You ever look at your name tag? You probably do it all the time. It's right there in your shirt. No. All right. So, 10.0.0.0.10.255.255.255 internal private addresses only. When they designed this stuff, they said, you know what? There are certain numbers that we don't want to work on the internet. It's like at Rose State, the whole entire campus will all use 10 something. Okay? And a lot of your companies where you work probably use that as well. Anyone know what Tinker uses? What do you use as a Tinker? Do you know? Anybody? No? I don't know what they use. I'm just wondering. What's the IP addresses of Tinker? Is it 10 something, or is it 172 something?
It's 10.
Yes, usually 10. Most companies use 10. But 10 is an internal address, which means it's going to work inside this school, but that's it. Can I connect to your 10 address at Tinker? Nope, ain't going to happen, because it's internal private only. 172.16 through 172.31. It's another private address scheme. It's a little bit smaller than the 10 block. It's just another one. 169.254. I'm sorry, let me skip it. 192.168. Let me, I'm going to have to draw on the board for this one. So those on the recording will have to just pretend. Okay. I had a router in my house. Not a router, it's a D. I had a router. Okay. My internal address was 66.210.163.128 was my network ID. That's internal. This is internal, okay? Okay, that was my inside address. This is the outside. Okay, so these private addresses we're talking about here can only be used internal. Okay, everyone with me? So all those addresses, the 10s, the 172s, the 192s, the 169s, can only be used internal. And that was mine. My external address was 192.168.4.5. That was my external address. No? Totally correct. Totally correct. When they first, this is when I first got my ISP at my house. They set it up. They gave me a free router. I'm like, sweet, a free Cisco router. But I couldn't put any ACLs in it. If you know what an ACL is, it's kind of like a firewall. So I basically had to let the whole world in my network. So, oh, it ain't going to work. So that lasted about 2 days until they could get me a router. When I got my router, they gave me their configuration so I could set mine up the same, then I could add my access control list. Well, they told me, yeah, your inside address is this, your external address is this. I'm like, what the hell? That can't be. So I teach this stuff every day. How can that be external? Anyone see it? I didn't see it right away. It is external to me, but it's internal to Cox. So between Cox and me, they're using these numbers, which is fine. It's internal to them. It might be external to me, but it's their internal saying, Ken Dewey's network is connected to the Cox network on that address. So it was my external address, but it really wasn't the real external. Because really, this was the external address people connected to me on. But since I ran an ISP, those had to be my internal. But when they first did it, I'm like, how can that work? Then the lady, she's like, but it's internal to us. I'm like, makes total sense now. So I was just another step on the internal network. See, the normal home user doesn't see that kind of stuff. So you have an address like that, you just don't see it. It's configured in your cable modem. All right, yeah, the 192 is internal only. But internal is not always internal. It could be, like I actually helped my friend this 2 weekends ago. I helped him set up some cameras at his house. If anyone wants to get cameras for your house, Foscam, F-O-S-C-A-M, are amazing. They work great. Real cheap, super easy to set up. Yeah, I'll even show you. Oh, I got like no signal in here, so you might not be able to see them. Let me see if they connect. F-O-S-C-A-M. Okay. There's my garage where my car is sitting right now. But it's motion sensitive, so I could have it alert me to stuff. I can move it, so it moves. It's also infrared. So if it's dark, infrared automatically turns on. But I have 3 of these in my house.
So you're wireless or wired?
This version doesn't record. These are wireless cameras. They do need electricity to plug into. They have a $100 version which does record. But this can send me alerts to motion alerts. It can, send me pictures of who's in my house. It can even, patrol, so I can set it to sit here and do this all day long. It was like $82. Awesome. I love that.
You have it going to a DVI?
No, I don't. I'm not recording them anyway.
Okay.
No, I'm not. Alright. But I could set them up through a DVR to record that. They have email notifications, they have FTP, so I could set it to every 10 seconds, upload a picture to an FTP server, all kinds of stuff you can do with it. But, no idea how I got there. But they're really good if anyone needs any. I don't resell them or anything, but I was just very impressed when I saw them. What it was on a Groupon. I didn't buy it. There ain't no way that crap can be any good. Because it was like $70 on the Groupon. So once the Groupon ended, I went and bought one. I'm like, I'm an idiot. And I loved it. I was like, wow, I should have bought them. It was awesome.
$10 difference.
It wasn't that much, I know. But still, I could have saved $10. Alright, so 192 is internal. 169.254. I think I've mentioned that one before. That's the automatic private IP address. Remember I told you if it can't get an IP address, it'll assign itself one? What happens is when they made Windows, they tried to make it for stupid people. They wanted to make it so if you had two computers sitting there and a switch or a hub between them, and that's it, they'll be able to talk. What happens is your machine turns on, it says, hey, I need an IP address, anybody got one for me? It waits 15, 30 seconds, no DHCP server answers, it's like, fine, forget that, I'll give myself one. So it does, it assigns itself one. I like it for troubleshooting, because if someone ever calls me, my internet's dead. I said, I doubt it. Could be, I doubt it. So I always say, what's your IP address? If they tell me that, I'm like, oh, DHCP server's down. Reset your router, fix it. So it's great for troubleshooting. If you ever see this, that means whatever's giving out the address ain't giving out the address. So I just tell them reset the router and fix it. So, okay? All right. This is addresses to host information equals 255. A broadcast is kind of like at Walmart. Hey, car with the white car, you left your lights on. They want to get the word out to everybody. That's called a broadcast. So network address that ends in that. Or host address. Now this is not true, but some of them start with 0, not all. We're going to cover that here probably Thursday. But so the host address is kind of like Treeline Drive. You really can't use that as an address because that's the street. That's not the house. And the broadcast is like rural Route 3. You ever get mail you look at it's like rural Route 3 or something? That's basically everybody in the Choctaw area. So that's the broadcast. Oh, I-40 Choctaw Road. Lowe's is starting construction in November. I was actually at a meeting last night. Oh my God, was everybody pissed? They were all. I was like, dude, build now, go for it. Neighborhoods are so pissed. I'm like, I live right there. Build away. Just north of the highway, opposite side of the street where they were. It's gonna be right there.
Because they're redoing the off-ramp and on-ramps.
Right. And the neighborhoods are bitching. Why are you doing it now when the road ain't been redone yet? Well, the reason is ODOT, Oklahoma Department of Transportation, was supposed to be doing the road right now. In 2008 and in 2010, they said we're redoing in 2012. That's today. It ain't happened yet. So Lowe's rescheduled theirs to do it at the same time. We'll build a new gas station while they're doing the roads.
So where did you say they put it?
Just north of the highway. Other side from where it was.
Oh.
Right in there, there's nothing there. It's like, when you're getting on the highway right there, it'll be right on your right-hand side. But everyone's like, why don't you just wait? They're like, we scheduled it at the same time they did. They changed their plans. We didn't. Why should we change ours to match theirs? And so it was, man, they were getting pissed. I was enjoying it. All right. Some techniques, okay? It says, let me see. Did they cover the rest? Oh, okay, they did. Okay, we're getting there. Okay. It's actually going to be next class. But, okay. Some techniques. Subnetting alters class full IP addresses, which we're going to see how to do. Okay. Bits, it says IP addresses representing host information change. We're going to talk about that. But it does reduce it. Okay. So if I had this whole entire second floor open as one big huge classroom, do you agree with me that you could fit more chairs in it than we have it now? Because now we got walls and doors, so we're losing some space by having rooms. If we had one big huge open place, we actually would have more room. But by subnetting, we're actually losing some of our addresses. Because for every network ID, you have to have a network ID and a broadcast for every network. So it's kind of like you have to have a door and a wall for every room. So we're going to see about that. Okay. Says the number of hosts, subnets available for subnames depend on the host information bits borrowed, which we'll see how to do. Okay? All right. We're going to pick up on slide 15 next time. It's kind of important you're here if you can, because it's kind of some critical information. Okay? Because it will be on your test. And you will have homework on it. Okay. We're going to start on 15 next time.